Hi Bobcats. In this video we're going to start looking at periodicity and ionic bonding. Periodicity is also sometimes referred to as periodic trends. Our goal for this video is to look at valence electrons based on where an element is in the periodic table. The valence electrons in an atom are all of the electrons that are present in the highest numbered shell. In this table, I've written out the electron configurations for the second row elements, lithium through neon. I've written both the full electron configuration and the noble gas shortcut version of the electron configuration. If we look at lithium, it has electrons in two shells, the first shell and the second shell. So the valence electrons are all of the electrons that are in that highest numbered shell, or the second shell. And this exponent of 1 says that we have a single electron in that highest numbered shell. Now, so we have one valence electron. I also want to point out that we can get that information from the noble gas version as well. If we look at beryllium, beryllium has the two shells as well, and so we want to look at only the electrons that are in the second shell, and it looks like we have two that are in that second shell. And once again, we can get that information just from looking at the electrons that are explicitly shown in the noble gas version. If we move on to boron, boron once again has two shells, the first shell and the second shell, but this time the second shell electrons are split between two different subshells. Well, the valence electrons are all of the electrons that are in that highest numbered shell, so we need to add together the two s electrons and the one p electron, which means we have 3 valence electrons. And once again, we can get that information from the noble gas version of the electron configuration. Well, if you look at all of the rest of the elements in this table, they all have electrons in the first shell and in the second shell. So for the valence shell, we're going to look just at the second shell. And so for carbon, we have 2 in the S subshell and 2 in the P. So 2 plus 2 gives us 4. For, and there's a typo. This should be 2p2 for carbon. For nitrogen, we have 2 s electrons and 3 p electrons, so 2 plus 3 is 5. For oxygen, we have 2 s electrons and 4 p electrons, so that will be 6. And hopefully y'all are seeing the pattern here. Fluorine has 7 and neon has 8. So as we move left to right through the second row elements, we go from having 1 valence electron up to having 8 valence electrons, and we can get that information simply by looking at the noble gas shortcut version, or we could also look at the full electron configuration to see it. When I do this in a face-to-face class, I sometimes have my students figure out how many valence electrons a wide variety of elements have, and then we compile that in the periodic table. Well, we just looked at the second row element, so I'm going to just write these in here. We had, already making a mistake. We have 1 valence electron in lithium, 2 valence electrons in beryllium, 3 valence electrons in boron, 4 in carbon, 5 in nitrogen, 6 in oxygen, 7 in fluorine, and 8 in neon. If we were to look at the rest of the elements that are shown here in the S block and the P block, we would find the same thing. We would find that these elements have all of the elements that are in a given column have the same number of valence electrons. So if we're talking group number 1, they'll have 1 valence electron. If we're talking group number 2, they'll have 2. Group number 3 has 3, and 4, 5, 6, 7, and 8. That's using the A and B numbering system. If we're using the numbering system that runs 1 through 18, we're looking at the last digit of the group number because, for instance, the noble gases are group 18 and they have 8 valence electrons. So this numbering system will tell us at a glance, based on an element's position in the periodic table, how many valence electrons it has. So just as an example, let's look at these 3 elements and figure out how many valence electrons they have. Sulfur is atomic number 16, and you'll find that it is in group 6A or group number 16 in the 1 through 18 system. So this guy is going to have 6 valence electrons. Calcium is atomic number 20. It's over in group number 2, so it's going to have 2 valence electrons. And indium is atomic number 49. It's over in group number 3 or group number 13, so it's going to have 3 valence electrons. So to predict how many valence electrons a main group element has, you simply look at the last digit of its group number.